Hello everyone and welcome back to my channel. Today we are going to explore prompt engineering, which is the art of crafting instructions for the large language model to get the desired output. It is an essential part of ensuring accurate and high quality responses from the large language model. It involves carefully designing prompts that communicate effectively the desired outcome, provide context, and guide the large language model to the intended outcome. Although prompt engineering guidelines and principle applies to all large language model in general, today we are going to focus specifically on Google Gemini's family. So if you want to become a high-skilled prompt engineer who can construct the prompts that deliver high-quality responses from the large language model, then this tutorial is for you. So let's dive in. Hello everyone and welcome back again. Creating effective prompts for large language models requires an interactive process of refining the prompt based on feedback and experimentation. Just as machine learning models rarely work perfectly on the first attempt, prompt development also involves multiple cycles of writing, testing, and refinement. The goal is to create a prompt that is clear, specific, and provides a large language model with sufficient context and time to generate the desired output. Rather than seeking a single prompt, it's more valuable to establish a systematic approach to prompt development tailored to your specific application. On today's video, we are going to talk about the following principles: writing clear instruction with delimiters, be specific, descriptive, and as detailed as possible about the outcome format or length. Specify the response format, few-shot prompting, specify the steps required to complete a task, give models time to think, reduce vague and ambiguous descriptions to avoid hallucination. So let's go ahead and see how to implement these principles. Alright everyone, as I said in the introduction of today's tutorial, prompt engineering guidelines and principles apply to all large language models. But in this tutorial, we are going to use Google Gemini's family and see how we can apply these principles. And in order to work with Google Gemini's family, you first have to go to ai.google.dev and get an API key and store it in the .env file in your local machine. Then in our Jupyter Notebook, the first step is to install the required library. And the first library is LangChain Google Gemini. So we'll say pip install LangChain Google Gemini. The second library that we need to install is Google Generative AI. So we'll say pip install Google Generative AI. And the third library that we need to install is python.env. So we'll say pip install python-env. Now we need to import environment variable. So we'll have a title here, import environment variables. Then the first step is to import OS, then from .env import load and find env. Then we are going to load the environment variable. We are going to find and we will set override equal to true. And to make sure the API key is loaded successfully, we'll say API key loaded and we'll check if it exists on os environ.get google _API _ key. The condition is not none. Capital N. Let's run the code and make sure it's working, and API key loaded equal to. Now, since we are going to implement multiple use cases and see how we can implement these principles and guidelines of prompt engineering, now I'm going to create a function that's going to be common for all these examples to generate a response from the large language model, which is going to be Gemini Pro. So let's now define this function. So we'll say define get underscore response, and the argument are prompt and temperature, and by default let's set it to 1. Now we will define our model, which is equal to GenAI.generative model, and we are going to specify Gemini Pro. We are going to use Gemini Pro model. Next, we will define the configuration. So we'll say generation underscore config is equal to GenAI.types.generation configuration. And we are going to set the configuration here. Temperature is equal to temperature. And top K is equal to 1. And top P is equal to 1 as well. I'm going to explain all these parameters later while doing the examples. Now we will get our response by saying response is equal to model.generate content, and we are going to pass the prompt, and generation configuration is equal to generation configuration as well. And finally, we will return our response.parts index0.text. This is the format where if you are using the latest version of LangChain Google Gen AI. So let's run the code, make sure it's working, and it's working. Now let's test our code so far by calling this function and see if we can get a response. We'll say print get response, and let's pass an example prompt: create a Python function that calculates the factorial. Okay, let's run the code, and I get an error here because I forget to configure the Gen AI. Okay, your default credential were not found. So in order to solve this error here, we have to say genai.configure, and we'll say API underscore key is equal to os.environ.get Google underscore API underscore key. Okay, let's run the code again. It's working, and let's call the same function again. And we get the response here. So far our code is working fine. Okay, next we will see how to implement the first principle. Alright everyone, so we'll start with the first principle, which is writing clear instruction with delimiters. Delimiters could be stars, plus, minus, hash, start, end, delimiter, and etc. To guide the model towards the desired output and minimize the chance of irrelevant or incorrect responses, we have to write instructions as clearly and specifically as possible. So let's take an example. So we'll say here text is equal, and I have already prepared a paragraph about natural language processing, and let's now define a prompt. Prompt is equal to f summarize this text. Now we are going to call the method that we defined before. It's called get response. We are going to pass the prompt, and finally we are going to print the output. Let's now run the code and check the output. Alright, and we get the summary. So while the model successfully here produced a concise summary, The overall output remains general. Maybe we want the summary to be written in a way that is easier to understand, or to be translated to another language, or to be in another format like HTML or JSON. So let's go ahead and check how we can improve our prompt. So we'll say here, prompt is equal to F. We are going to say summarize the text delimited by triple backticks. This is the first instruction. Next, we are going to say translate the summary from English to, not Arabic, let's say French. Okay. And here we are going to say text is, we are going to put here the backticks, which are the delimiters, text. And again, here we are going to say output is equal to get response. We are going to pass the prompt and print the output. Let's print the output and check. And we get the response as we can see here. It summarized the text and then it translated to French. So that's what we mean by placing the instruction at the beginning of each prompt. Now let's look at another example. Suppose we receive an email which is equal to the following. I have prepared a test email. It has a subject and it has some tasks assigned to employees, okay, with a due date and some instruction as well. Okay, so let's here now see an example of a prompt with clear instructions. So let's define the prompt and provide clear instructions. So we'll have prompt is equal to F task, extract the task, assignee and due date from the email below. Format, let's see, let's put it in a new line. Format the output as a table. Now for delimiter, we can use the following. Delimiter start, we'll use 3 here, which is email, and then 3 delimiter end. So here we state the intended goal for the large language model. The delimiter start and delimiter end clearly separate the instruction from the raw email content. This prevents the large language model from misinterpreting the parts of your instruction as something to the process. And the request to output a table adds an extra layer of clarity and helps ensure the large language model produce structured data. Again, here we'll say output is equal to get response. We are going to pass the prompt and print output. Let's run the code. I get an error. Email is not defined. Oh, we forgot here to run this code cell. Let's run this code again, run. And we get the output as we ask it to. We have the task, assignee, due date as the header. The task, the first one is draft the proposal for Sarah on this date and finalize the budget spreadsheet for Mark on this date. Okay, so that's all about the first principle, which is writing clear instructions with delimiter. Now we will explain and see an examples of the second principle, which is to be specific, descriptive, and as detailed as possible about the outcome format or length. To get the most accurate and helpful responses from our large language model, we need to be crystal clear about what we want in return. Think of it like ordering at a restaurant. The more specific you are with your order, the less likely you are to get something unexpected. Let's see how to apply this by crafting prompts that precisely describe our desired output format. Suppose that we have a review about a product and we want to analyze it. So say review is equal. I have already prepared a sample review. Now let's define a specific, descriptive and detailed prompt. So we'll say prompt is equal to f. I have already prepared a prompt. It is analyze the sentiment of the following product review, provide the following output. Overall sentiment, clearly state whether the review is positive, negative, or neutral. Assign a numerical score from -1 very negative to +1 very positive, representing the review's overall tone. Okay? Then we are going to say now output is equal to get response, and we are going to pass our prompt. And finally, print output. Let's run the code. And we get the specific instructions that we ask the large language model to provide us. The overall sentiment is positive and sentiment score is +0.9. And that's what the specific, descriptive, and detailed prompt is. Let's take another look at another example. We will have a prompt is equal to f. We can say we want to summarize the text that we wrote before about the NLP. So we'll say summarize the text delimited by triple backticks in at most 40 words. 30 words. Text is equal to backtick text. Alright. And again, here we will type the same. Let's run the code. And we get the desired outcome. And if you want to check if it is less than 30 words, we can do the following. Print f summary length in words is equal to length of the output dot split. Okay, and it is 17 words. And if you want to be more specific and more details, we can say the following. Prompt is equal to f. I have already prepared a prompt. I'm gonna copy and paste it here. Summarize the text delimited by triple backtick. We want to begin with a summary with an introductory sentence followed by a bulleted list. Okay. Now we can say again and we get the desired outcome. And as you can see, we get what we want by being more detailed and specific. This is a very good prompt, but of course we can improve it by providing more specific and detailed instruction. Alright? One note here is that don't confuse writing a clear prompt with a short prompt. In most cases, long prompts provide more context and clarity for the model, potentially leading to a more relevant output. And if you want to be more specific also, we can provide the steps needed to complete a task. Let's look at an example. We have prompt equal. I have already prepared a prompt, which is write Python code to calculate the area of a rectangle. Follow these steps. Here we are instructing the large language model to write a Python code to calculate the area, and we are instructing it to use the following steps. Begin with a definition statement to define a function, and we are calculating the area using the width and length. Inside the function, calculate the area using the formula, the exact formula we are telling it, and return area statement to return the calculated result. Alright, let's run the code and check the output. And as you can see here, it returns the exact output that we want, with the definition, with more details here, and also with an example. Alright, that's it for the second principle. Alright, now we will talk about the third principle, specify the response format. Think of an LLM like a powerful but somewhat unpredictable tool. To truly harness that power, we need to provide guidance. And one of the best way to do this is by specifying the output format. This will let us control whether we want concise text, code, or even something more elaborate like a styled web page. Let's see how this works. I have prepared an example without specifying the output format. Let me just copy and paste and see the result. We have the following prompt. We have an existing item in a room. We have modern sofa, painting, rug, and bookshelf. The room type is a living room, and the design style is what we want is Scandinavian minimalist. The prompt is design a room using the following existing item. Adhere to the design style aesthetic. Alright, we are not specifying the output format. Let's run the code and check the response format. Okay, and we get the response here as a text. Okay, now let's update the prompt and ask the large language model to return the response in HTML5 and CSS. Now this is how we specify the output format. We want it to be in HTML5 and CSS. Existing item, we are going to use the same, room type the same, design style the same. And the prompt, design a room type using the following existing item, okay? Adhere to design style aesthetic. This is what we had before. Now this is here how we are specifying the output. Instructions, the design must incorporate all the provided item. Respond with HTML5 code to structure the following content blocks. We want to have a short paragraph, a list of suggested items with brief description, and color palette displays 3 to 4 color swatches with their hex code. Okay, include basic CSS styling as well. Alright, let's run the code now and check the output format. And here we can see we get the response back in an HTML format. We have here the style, the CSS, and here is our HTML elements. Now, if you want to display the output this in Jupyter Notebook in HTML format, we can do the following. We'll say from python.display import display HTML. Okay, and then we can say now display HTML and our output. Let's run the code now. And as you can see here, this is the format that we get from the large language model. It's more readable, aesthetically pleasing as well. We have here the Scandinavian minimalist living room design. We have two introduction here, and here's the design that required for and the swatches color. Alright, so that's how you can specify the output format for your prompt and why it's important. We can think of three things. First, accuracy. A well-defined format makes the large language model output more usable in our projects. The second reason is efficiency. We save time by avoiding the need to reformat the large language model response manually. And creativity. Sometimes requesting specific formats can spark unexpected and innovative solutions from the large language model. Alright, so that's it for this principle. Alright guys, now we will talk about the fourth principle, which is few-shot prompting. But first, what is few-shot prompting? In traditional machine learning, models often require massive amounts of data to learn a task effectively. Few-shot learning aims to train model using only a very few number of examples. During the prompts, we provide a few examples that illustrate the tasks that we want the large language model to perform. The goal is for the large language model to recognize the pattern from this example and generalize to new unseen variation of the task. Here I have two examples. This one here is called zero-shot prompting, and this one here is called few-shot prompting. The difference here is we provide two examples of the word here. This task we want to find several synonyms for the word below, for the word happy. We provide two examples here. For beautiful, the synonyms are stunning, gorgeous, attractive. And for large, we have big, enormous, vast. So we give few shot prompting here to show the example of what we want, alright? And here we gave nothing. This is the zero shot prompting again. So let's run the code and check first the zero shot prompting. And we get the result. It's good, but if we wanted the result in a specific format, as here, we gave two examples, alright? Let's run the code here for the few shot prompting and see the result. And we get the result. As you can see here, the format is exactly what we asked for here, similar. We have the word happy, the synonyms are joyful, cheerful, merry, delighted, overjoyed, okay? So the difference between zero shot and few shot is that in zero shot, we provide no example with the prompt. The large language model relies on its pre-existing knowledge and the instruction in the prompt to try and perform the task. On the other hand, by using few shot, we provide a few examples within the prompt to help the large language model understand the pattern and intent of the task. And why it's important to have a few shot learning. First, for adaptability. A few shot learning makes large language model more adaptable to new tasks without requiring a huge data set for each task. And the second thing is real world use. It's closer to how humans learn. We often grasp a new concept from just a handful of examples. And third, efficiency. It reduces the need for time-consuming and expensive task collection and labeling. And that's it for this principle. Now we are going to talk about the specified steps required to complete a task. When interacting with large language model, remember that they don't often understand tasks in the same way as a human. One of the most powerful prompt engineering technique is breaking down tasks into smaller sequential steps. This provides the large language model with a clear roadmap, and it will make it much more likely to successfully complete what you have asked it for. Okay? So why it's important also to provide the steps? First, for clarity, step-by-step instructions reduce ambiguity and the chance of large language model misunderstanding. And second is that if we have complex tasks, it will make it easier for the large language model to handle tasks that have multiple parts or dependency. And finally, for the success rate, it will improve the likelihood of the large language model producing the correct and desired outcome. Here we have two examples. The first one, here we did not specify any steps. And in the second example, we took this prompt and we improved it by adding the steps required to get the desired outcome. Let's run first a prompt without any steps and check the result. Alright, so here we have original text. The project is taking longer than expected and I'm worried about the deadline. We gave task to the large language model, rewrite this passage to sound more cheerful and optimistic. And the output was here, revised test. Our project is progressing steadily and with our unwavering determination, we are confident of meeting the deadline. The journey may have unexpected detours, but we remain optimistic and focused on the end goal. It's a good result, don't understand me wrong, but what if you want something specific in specific format? But here we ask the large language model to identify the word, the negative words, and replace negative word with positive alternatives, and adjust sentence structure if needed to emphasize the positive aspect. Let's run this code cell again and get the result and compare it to the previous one. And here's what we get. You see, it's totally different than what we get here. Here it was short and concise, but here, according to our step, it was perfect according to our specification. We could even take it a step further and ask it to write it in HTML format. So without the steps, we rely heavily on large language model understanding of our language and tone. but with the steps specified, we provide guidelines for the transformation, which will increase the likelihood of the large language model achieving our desired outcome. And that's it for this principle. Let's continue. Now we will talk about this principle: give models time to think. Remember, even the most powerful large language models are not as fast as the human brain. Complex tasks or those requiring multiple steps of reasoning may need a bit of processing time. So one important prompt engineering technique is building in pauses or delays to allow the large language model to fully think before responding. This often leads to higher quality and more coherent outputs. And the benefits will be, first of all, accuracy. By giving the large language model time, can prevent premature responses with incomplete or incorrect information. Second, thoughtful generation. Especially for creative tasks, these pauses can allow the large language model to explore more possibilities, and it reduces error. Given model time to think helps avoid the large language model getting stuck or producing illogical output due to a rushed process. So let's now look at the examples here. Here's the first prompt. It's just we are asking us analyze the impact of social media and modern society. However, here on this prompt, we are asking first, please take the necessary time to carefully consider this prompt and access relevant information from your knowledge base. We are asking the large language model to take the necessary time, and then we are giving it the instruction. Start with an introduction and then follow task in bulleted points. Here is the task. Analyze the impact of social media on modern society. Structure your response as follows. For positive influence, we ask it to pause for 4 seconds. For negative influence, pause 5 seconds. And for societal shift, pause for 4 seconds. These are intentional pauses. The word pause and the duration gives the large language model time to process each stage of the story generation. The longer the pause at step 3 encourages deeper consideration for a more creative turning point. Alright? Let's run the code cell now and check the results for both and compare them. We'll first run the normal prompts here, the standard one. And we get the result here. And as usual, it's good, okay? But what if you want more accurate and you want the large language model to think? Let's run this code now and check the result. And we get the response here. One important note here is that how you implement these pauses may depend on the specific tool or API you are using with the large language model. And here we get a structured analysis. The prompt guides the large language model towards a well-organized responses. We have an introduction, positive, negative influences, and the societal shifts. And this structure of our prompt, encourages the large language model to address both benefits and drawback. And that's it now for this principle. Let's go ahead and see the last principle. Alright, now we will talk about the final guideline and principle in this tutorial, which is reduce vague and ambiguous description to avoid hallucination. As we all know, large language models are very powerful, but they can sometimes hallucinate, meaning they generate text that seems accurate, but it is incorrect or unrelated to the task. One of the leading causes of this is vague or ambiguous language in our prompt. By being precise and specific, we can greatly reduce the chance of large language model straying off course. Alright? Let's look at an example here. We have here a prompt where we ask the large language model to write a story about a friendly dragon. It's very vague and ambiguous description for the large language model, so let's run the code cell and check the result. Alright, so we get the result here. It's very general, alright, and creative as well by the large language model. But now we want to be specific. We'll say write a children's story about a small a green dragon named Pip who loves making flower crowns. Sorry. When Pip accidentally sets a field on fire, he learns a valuable lesson about responsibility. So let's run this one now. Alright, and we get here a more appropriate response according to our description, which include the flowers and the crowns and setting the field on fire accidentally. Okay? What happened here is that the original prompt leaves too much to the large language model imagination, increasing the likelihood of unexpected plot lines or details. But in the second prompt, we provide a clear instruction which establishes personality traits and outlines a central conflict, and this will give the large language model a strong foundation to build upon. So, but what are the benefits here? The benefits are, one of them is accuracy. With clear prompt leads to outputs that better align with our intent. And reliability, reducing the need to constantly shift through irrelevant or incorrect large language model responses. And of course, it will prevent hallucination. By being very precise and specific, this will help the large language model stay grounded in reality, especially for factual tasks. But of course, sometimes a degree of openness is good for creative tasks. The goal of the prompt is to strike a balance between guidance and the large language ability to fill in the blank. Now let's look at another guideline here. So always avoid to use negative words. Let's see an example. Suppose we have the following prompt, which is equal. Write a product description that does not make the product sound boring. We'll have here output, which is equal to get underscore response. We are going to pass the prompt and print output. The problem with the not word here can sometimes confuse the large language model, especially when the task itself is somehow abstract. How do you define boring? For example, like what is boring for large language model? For example, for us a human, we know it's our personal perspective. We know if it's boring or engaging or something like that. So in order to improve this prompt, we can write the following. Prompt equal write a product description that is engaging, exciting, and highlights the product's unique benefits. Okay, we'll have here again output is equal to get underscore response. We are going to pass the prompt again here and print output. Let's run the code cell and look at the response. Alright, and we get the response here. Now, here we focused on the desired outcome. Alright, the rephrase version here in this prompt shifts the focus towards the positive quality that we want in the description, which will provide clear guidance for the large language model. So always, guys, avoid using negative words such as not or does not exist or boring, okay? So that the large language model be able to understand what you are talking about. And now let us look at the final example for today's tutorial. How to avoid hallucination. Let's see an example. Suppose we have the following prompt, which is equal write a product review for the new flip iPhone from Apple Incorporation. Alright, of course there's no flip iPhone, so let's check the result. Output is equal to get underscore response prompt and print output. Let's run the code and check if it's gonna generate a product review. Alright, and that's what we mean by hallucination. Apple Flip iPhone does not exist, but it generates a review for this. Now, how to avoid the hallucination? I will show you one of the technique. Let's copy this code and paste it here and update the comment. All right. So we'll add here, write only facts about this product according to sources such as Wikipedia, Google Scholar, Britannica, or other reliable public sources. Okay, so we are asking it to cross-reference with the following sources. Also, we can add the following: avoid speculative or fictional content. All right, we are asking it to avoid any speculative or fictional content. And finally, if you don't find information in reliable sources, just respond with I have no information about this. Okay, let's run this command again for the same new Flip iPhone and check the response. And we get an accurate response. I have no information about this. Always avoid hallucination while writing your prompts. Alright, that's it for today's tutorial. I hope this tutorial has equipped you with the necessary skills to get the best out of your interaction with large language model. Don't be afraid to experiment, refine your prompts, and see what amazing result you can unlock. The world of prompt engineering is always evolving. If you find this tutorial helpful, don't forget to subscribe to my channel in order to learn more about prompt engineering and generative AI with large language models. And now it's your turn. Think about a task you often do and how you might use prompt engineering to improve it. Whether it is writing better email, getting creative inspiration, or for example, analyzing data, the possibilities are endless. Let me know in the comment what exciting things you tried. Alright? Thank you for watching and see you in the next tutorial.